never spoke at JSpring, been to a couple of them. And also, this is a very new talk. So let's see how this goes. Never done this before. So welcome. I'm going to talk about how you can organize your Java backend. The lessons learned in my years of experience and things that I do regularly at my job as an architect, and I did as a part of my job when I was a consultant. It's a mixed bag. There will be a lot of topics here and there, jumping around from one topic to another, showing a couple of demos on how to do stuff. Some things maybe you're aware of, some things you don't. Let's see. Before I start, I have to give a shout out to two people who was part of my last team when I was working at my previous company. And they have a huge contribution in this whole presentation, what I'm going to do. There are code samples, there are pipeline ideas, there are repository settings, which these two guys were not there, wouldn't have happened. So I have to give them a shout, along with the rest of the team, who I couldn't put all the pictures, but anyway. Who am I? I am a cloud solution architect working at Microsoft. We primarily work with startups. They make SaaS applications. So if you're a SaaS vendor, probably working on Azure, you might work either with me or one of my colleagues. On my free time, I like to watch football. I used to play, but last 2-3 years, not been possible anymore because of Corona and everything, and I'm getting old. I'm a tech enthusiast. Whenever a new technology comes in, I jump into it, try to learn it, try to play around with it, break it. I have lots of unfinished projects in GitHub. And yeah, you can find me on all these social channels. Although I'm not really a big social posting aware guy, but I'm there. Whenever I find something interesting, I try to post it there. So what are we going to talk about? We're going to talk about a little bit about workflows and pipelines. How many of you use GitHub for repository? And GitLab? OK, so I'm mixed. So I'm going to try to put both the terminology together, but yeah, we'll see how that goes. So I'm going to talk about how we can actually make a good pipeline or a workflow. What are the things you're going to look for when you build something like that? The things that we face during the build of our pipeline or our workflow. I'm going to talk about a bit of a repo management. Some of the things may be a bit repetitive for you or you already know. But there were some gotchas which we also saw when we are actually starting up a new project. And that might be interesting when you are also working or doing something with repo management. I'm going to talk about a little bit of Maven tricks that we did, APIs, microservice environment, and I'm going to talk about a few handy stuff here and there, which we did also in our projects, and see how that helps you. So as I told you, it's a mixed bag, a lot of topics, a lot of different stuff. So let's start with workflow and pipelines. The first thing I suggest you do is invest time on your workflow and pipeline before you start coding or pushing anything in your repository. It helped us a lot because we standardize everything. This is the stuff you do once and you forget the rest of your life. Or you only do small changes here and there. And the problem is, nobody is expert on this. We Googled every step. And I'm pretty sure everybody who is actually coded a pipeline or workflow did the same. And that goes on and on. But the point is, if you do this as a first exercise, you find it, what are the repeatable states? What are the steps and the jobs? You will do it always. What are there any common stuff between your microservices and the libraries? Are there any common stuff between your packaging as a POM or a packaging as a jar or a packaging as a war? And that gives you a lot of thinking, take a step back, and build this. Because as soon as you check in your first code on the repository, somebody from your team, most probably your manager or a PO, is it deployed on dev? And you don't want to do that as your first step also manually. Because once you start doing it, it becomes a habit. And that habit will go away very, very, very tedious way. So invest on the pipeline. And once you invest on there, you will slowly realize it's not only compile, push to a registry, and deploy. There are other stuff happening around. You're going to start soon asking questions about how am I going to do QA on this? Am I doing integration tests? Should I do it at all or not? Should I separate my CI from CD or not? Should I make reusable pipelines or reusable workflows or common pipeline out of it? Is there some way to minimize the burden of onboarding new people? So when somebody comes into your project and they start building on a new microservice, they love it, but as soon as they want to start changing a YAML file to create a pipeline, they will hate it because they don't know how to do GitLab, they don't know how to do actions in GitHub. Most probably, they would not know how your project standards looks like. So you also want to minimize the way of how you onboard a new guy in your project or on a new person in your project. So this helps a lot. And when we start doing it, we realized there are pretty basic steps in your workflow or a pipeline. You want to compile for a Java, by the way. You want to compile, you want to test, you want to package it, you want to deploy it to an Artifactory somewhere, Nexus or JFrog, and then you want to build an image maybe using buildpack or even your Docker file, and then you want to push it to somewhere, and then you want to deploy it to your Kubernetes cluster or somewhere else. And once that is done, you might also want to run integration test, and if that fails, you want to roll it back. So pretty standard. There's nothing basically different about it. But once you look deeper, you'll see if that is running for a Spring Boot project or any Jakarta EE project, you also can use some of the steps for your libraries, which are just generating jars. So your internal library, like doing encoding, or having POJOs there, or having your Kafka objects there, or having your event objects there, those stuffs will also can use the same pipeline or a workflow that you're going to generate. There is a QR code for the reusable workflow from GitHub. If you're not aware of it, please go ahead and check it. Yesterday, Ishel at Utrecht Jug also talked about a lot about reusable workflows. So it helps you to define it in a central position, and all the people, all the other repositories who are using it just need to refer to it. So they are not writing the whole steps again. They refer to a common workflow or a reusable workflow, and just pass parameters to it. So for example, name of it, a version of the Artifactory you build, or if you have a special thing to do a deployment or not. As soon as we build that as our first step and started working on our repositories, we soon realized it takes too much of time. It takes too much of time to do QR. It takes too much of time to run integration tests. It takes too much of time to push to a registry. And the developer productivity went down. We had a branching strategy, or normally when you follow a branching strategy of feature branch to develop to main or tagging, your feature branches are short-lived branches. And there you do your regular development. And those branches doesn't have to follow all the steps. And soon we realize it is taking a lot of time, and we cannot waste that time anymore. And what we saw, very interesting statistics in GitHub, that most of our developers actually was canceling all the workflows of feature branches. Yeah, who cares? Because at the end of the day, I'm going to commit, go home, start tomorrow, or I'm going to quickly push it to develop and see if that develop a cluster to see if that works and roll it back out. These steps were taking too much time because there was OWASP check for every dependency that you push in. That CV checks takes time if you're not having a cache. We had a mutation test, which actually mutate all the source code and run your unit test, was taking long. That doesn't make sense when you just want to build something, test, and get on with it. So we had to do something. So the first step we did was remove the QA from the main build. So only when you are pushing to a develop branch or a higher branch than your feature branch, let's say for the sake of that, then only you need a QA. So if somebody changed something on a feature branch and want you to review, that person, you as a reviewer, want to know whether this code is good to be pushed to the higher branch. And that's where the QA makes sense. So the mutation test about how much coverage it has, or a Jacoco plugin to check how much Sonar coverage it has, or your OWASP checks can be done later. So you can put that as a review command, or the person who is making the pull request can check if my review workflow is green, then I only can ask somebody to review it. And it took a lot of time out of the build, so it was only build, test, and package, and then deploy. All the QA out of it. And this scanning, checking happened on the merge or pull request. We also did something different to manage OWASP. How many of you do OWASP plugin, actually? OK, quite a few. So this actually checks vulnerabilities on your dependencies. And every project so far I've been to has always a standard of checking your dependency, how vulnerable it is, and if there is a CVE higher than 7 or 8, you need to resolve it. Same as Log4j, everybody aware of it. So it came out that way as well, but not every CVE is actually relevant for your project. Once you start looking at it, my suggestion is do not blindly update all dependencies if you see an CVE. Check the details, check if it has an impact, because we had in Spring Boot 2.7.3, I guess, or 2.7.2, a CVE which we didn't use, actually. It has a problem with if you deploy it on a WebLogic or a Payara server, then it has a dependency to it. But we were running on Tomcat, so we could easily avoid it. So what we did, we created exclusion list. But once you grow your project, you will have more than multiple repositories. And every repository would need to have that suppression XML. So OWASP requires a suppression XML to omit the CVE. So every repository having a suppression XML was actually getting too much for us. So we wanted to centrally manage it so that we can also see what is we are excluding. So at one go, open an XML file or export it to a wiki so that we can easily report back to our client that these are the CVEs we are not checking or skipping it. So we do not need to go ahead and check all of it. So what we did was separated out the suppression XML. We added as a Git submodule. How many of you are aware of Git submodule? OK, quite a few. Git submodule is basically making sure a remote repository is available in your repository. So making sure you are making a reference to a different one in a very short term. But I'm going to come back to Git submodule in a bit, in a later part of it, because when I'm going to talk about API sharing and all. But what we did, we created a separate repository, put all the suppressions there so that it's centrally managed, and it's been looked after, it's been reviewed by different people. It had a different code owner, so you and I adding a suppression doesn't mean it's gonna be suppressed. It has to be reviewed by somebody to add it to the suppression list. So you can also think about a different review strategy for your centralized managed CVE list. And then you add it to every repository you have, and the build will pick it up because every submodule will be added at the time of your build. So once you check out your repository during your build, you also have to add an extra step to update your submodule, and the submodule will add the XML file in your build path so that the Maven will think it is part of your repository itself. So, repo management. Branching strategy is a very complex topic. Everybody has their own opinion about it. The QR code below is a blog from IntelliJ, which talks about how Git flow being introduced in branching strategy, which is pretty much similar to what I am going to talk about right now. So the way we divided the branches, where we had a main branch, where we use it for releasing. So every release got a tag, and every tag gets ultimately down to different environments. And we also had a develop, which was actually supporting all the feature branches. So if you have multiple developers working on the same repository, different user stories maybe, they have different feature branches available. And at the time of merge or a pull request, it all goes to develop. And when you want to release automated or manual, you push it to main, and then it gets released. What it did from helping us is it made our release process very streamlined. And this is not only for microservices, but also for your libraries. So when you're doing a branching strategy, my advice is do not separate your libraries from your modules or microservices. Have it same, because they are basically, at the end of the day, creating artifacts. So it helped us to streamline the release strategy. And when we push it to develop, it always has a snapshot in the Maven. But when you go to main, we remove the snapshot and create a release tag to it. This actually helped us to create automated versioning inside our build pipeline itself, or a workflow. So what we did is, if you push something to main, we check if there is a snapshot version associated with the Maven version. We remove it. We push it to main. We go back to develop. We hire the snapshot version, push it to develop, and then create a tag from main and release it. All of this happened. By the way, there are tools available to do it, but the way we did it was a bit of different. Oh, this is not open. Let me open it. Yeah, come on. It's not very visible. Oh. So what we did was we checked out the main branch. We checked what is the version of it. We removed the snapshot from the main. We put the develop branch higher a version using Git Maven commands. And we also created tags out of it. What we also did, we canceled the workflow for the tag branch and the develop branch, because the build pipeline was on an event of push. So anything you commit, going to trigger the pipeline. So we also had to skip the pipeline when we did the changes for it. How many of you have ever deleted a main branch or a develop branch? Okay, then it's me. Okay, 2 of them. Thank you. I deleted a main branch not only once, actually twice. So yeah, it's very important to have branch protection rules. I know this is very trivial. You might not want to do it. Your DevOps person is already have done this. But it helps if you create a script on creating repos, because there are a lot of checkboxes sometimes that you forget to check. There are code owners, there are reviewers. These you want to add automatically. So my suggestion, if you're using GitHub or GitLab, create a small script which creates new repository for new microservices libraries. That helps you to standardize your branch protection rules. Your main and your develop will be protected. Who can push or commit to main and develop is protected. There should be no deletion happen. You can also think of signed commit and push. You can also think of merge request or pull request should be properly reviewed, no comments, everything resolved. So things like that are pretty useful when you are actually managing a branch or a repository within GitHub or GitLab. This is a very, there are 2 sides of the coin. So some people are for directories, some people are for branches. What I'm talking about is there's a lot of projects I've been to where production, test, development has different branches. So anything happens to production has changes to production feature branches, and then push to production. Anything to test, test to test branch, then dev to dev branch. Which is fine, to be honest, but as soon as you have to do the same change in all those branches, you'll have to do it in every branch separately. So cherry pick every specific branch to make the same changes again and again. This is an example from Customize. Customize actually has a directory strategy than a branch strategy. So you create different directory for your overlays. So think about your environments at different directories, and every directory has a delta of your configuration rather than the whole file. You can also think about in a Helm way. In Helm also they have directory structure to do the overlays. So similarly like that. So my suggestion is choose for directory structure rather than branch structure, because then your branches are going to be same. You're going to push for test, prod, and dev on the same way you do it for any other environment. I am a very big believer of CI and CD separate. Your repositories which you're working on, microservices, libraries, their life cycle is change a code, do a build, create an artifact. That's it. And there should be a separate asynchronous workflow or a pipeline which will do something with that artifact, either to deploy it or to publish it or, I don't know, push it somewhere. The tool that does it out of the box for this is Argo CD, but the concept is very much similar. So let me ask you a question. If you want to scale your app from 4 pods to 5 pods, do you want to do a release of your application? Think about it. I don't think you should do that, because the config is totally different than your versioning of your application. Versioning of your application gives you a new feature or changes something or fixing a bug. But application configuration is something which you are actually managing how you are, how your application is going to behave at runtime, or what are the properties you are passing. So there's another example of secrets. So microservices, when we build, either communicating to a database server or a file system or something else, and those login details changes every X days or X months. And if you manage that within your application itself, along with the code, you're also going to change it every few X months. If you separate that out, you can think of a different way. Another example is innovation. So when you are trying to innovate within your CD space, so we started with Kubernetes, moved to Helm. So tomorrow, if you want to introduce Argo CD or something else, your CI pipeline is not really impacted by that. It only goes on to the CD side. So it helps you also to innovate separately. Your app projects will innovate separately. Your config projects will innovate separately. Now, move on to Maven tricks. This is also a quite divided space. I'm quite familiar and a supporter of parent POM. Why we did that? So remember, we are talking about centralizing your pipeline and workflow. So there were a lot of steps which are pretty much common. And all those steps uses some kind of dependency or plugin to do that one. So for example, if you're doing a Docker build within the Spring Boot Docker plugin, then that plugin need not to exist in all the POMs in all the repositories you have. If you want to upgrade the Spring Boot version or even the Java version of it, you don't need to change all the POMs which are there on your, in your project. So having a parent POM helps. It also adds a lot of complexity, but it helps because you centrally manage your dependencies, your plugins, and define what you're going to do with them or what our profiles are there, and some other stuff which are very common to it. The other option could be is creating a custom plugin which will generate your skeleton repositories using Maven. So if you do Maven, artifact, blah, 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 then it will create the scaffold application. But then all those upgrades of versioning and all is not centralized anymore. So it helped us a lot when you do the dependency management and define the versions upfront on parent POM. And to our surprise, we could use the same pipeline to it because the packaging was POM, and at the end of the day, it was creating an artifact for your artifactory. So it went to Nexus and JFrog using the same pipeline. It's not a jar, but it's a POM. And you release the same way you release any other application or repository in your project, basically. So all libraries or microservices, it also gets a higher version. And once you're consuming it, you also actually consuming a higher version of that parent POM in your repository. Enforcer. How many of you have seen a class not found or method not found and check the dependencies and say, what's happening? So we had that as well. Please introduce it as soon as possible. It helped us with the parent POM structure as well, because if you put a plugin, it's going to impact everybody if they use that parent POM version. That QR code is from Andreas. He is also there later on speaking of, about Maven puzzlers. I strongly recommend you guys visit that. He going to talk about a lot of Maven tricks there as well, and it's a fun talk to be in. So it helps you to enforce a lot of things. It helps you to enforce no duplication. It helps you to converge all the dependencies. So if you have different library versions being included transitively, it helps you to make sure it picks up the higher one or the lower one, depending on how you define those rules. You can define the upper bounds of it. You can define the lower bounds of it. And basically, you make sure there is a gatekeeper always available to check any of the dependencies that are being used in your code are not also going to create a class or method not found errors. So my suggestion, as soon as possible, try to use Enforcer plugin. Time is good. API management. OpenAPI, I think, how many of you are using OpenAPI standards? Okay, everybody. So most of them. So OpenAPI is pretty much became the de facto way of defining APIs. And if you are working with microservices which are connecting internally or externally, my preference is always API first approach. So you define it, then you generate everything. So the generation goes into also consuming and testing part. So if you are having integration test based on those definitions, you can generate your basic client APIs using that. For code generation on the server side, the clear winner is OpenAPI generator. Even though I don't really a big fan of it anymore, because you know the reason, I'm not sure how many of you are aware. First of all, it has 33.7K open issues. Secondly, I'm pretty sure you have never read this, but look at the last line. They are not really associated with OpenAPI at all. So any changes or innovation, features added or removed from OpenAPI standards will probably come here much, much later. Be very careful about that. But having said that, it's a clear winner because it gives you a lot of options to generate server code. It has a lot of configurations which you can tweak to do that. There are limitations, I know, if you're using all of and all. But it's still the best way if you're doing server implementation from your API standards. But for the client, I would suggest try to check out Kyoto. Kyoto is a tool which is also open source, and contributed from Swagger community itself. So it's a collaboration between Microsoft and OpenAPI to create client. And it's based on OKHTTP, and you can use it as a client in your consuming application or in your integration test. Let me show you. So I have an API spec, which is basically has a user, get, and a delete. And the part which is very interesting is it uses polymorphism for definition of the object. So I have a user object, which is kind of the superclass, and I have two different objects based on it. One is a manager, and one is an employee. And once you go to these kind of complex construction in OpenAPI specification, you will run into the corner edges of OpenAPI generator. And if I run this, I always get a warning about all off, because I use an all off feature from OpenAPI. And it doesn't give me any errors or warnings if I use in Kyoto, because that is much more stabler than OpenAPI. So OpenAPI generates also classes. And if you have never worked with it, it will going to generate the model classes for you, and it generate the controllers for you as a server. And it is pretty much straightforward to use it as well. So you define where is your YAML file, and what kind of generator you're going to use, which is the very, very powerful part of OpenAPI, which I believe, that you can specify what kind of framework you want to use to generate the servers and clients. And then basically your API package and few other configurations. Same goes for server. I'm going to come to a little bit later on how I'm going to sharing this API definition. But for the client, it uses a different plugin. Basically, it's a Kyoto plugin developed by Red Hat. It's also an open source plugin. And you specify only where your definition lives. And it generates the file for you, which is also similar as models and your API builder, and you basically call your clients. As soon as we had the API definitions ready, we realized how we're going to consume it. How many of you have copied over API definitions to different repositories to create clients? 1, 2, 3, 4. Good. So we had two options when we actually tried to consume it. One is the get submodule way. So you define your API definition in a central place, and then you reference them to all the repositories which are doing something with that definition. So generating server, client, or writing test, whatever. It had one problem. We couldn't use the same release cycle of the API definitions as well as any other consuming applications. So when you JIT submodule it, you always reference to a branch, and that branch is not really a release. So we wanted to consume everything from the artifactory itself. So Nexus or JFrog, wherever you're pushing your artifacts, that's where you want to consume it from. So what we did is a little bit different, and also can be a little bit controversial. So what we did, we pushed the API definition with the server itself. So when you change your API definition, basically you're changing your behavior of your server. And we released that server artifactory as a higher version to the Nexus. What we did on the consuming side was we added that server as a dependency to the consumer. We unpack that. We only read the API definition out of it and generate client classes out of it. And all this done on the build time, and none of the other part of the server jar is included in the client. We only use the generated class out of the API definition to consume it. How does it look like? It looks like pretty straightforward, actually. So it has a unpack plugin, which does an unpack of the dependency. So this is the dependency which we push in. This is the server, basically. So if this gets a higher version, you also can change the higher version to it and consume that higher version. You generate extract the API definition out of it, and which is basically somewhere here. This one, generated source, yeah. So this one, and then we use this YAML file to generate everything else, all the models and the clients that you need, and then you basically use that in your consumption repository. So what it helped us is basically having the same release cycle for your API definitions as well. So we also, basically followed the same workflow, same pipeline, same release process when you are changing your API definitions. So OpenAPI generator also has a generation of client APIs, which is also, the powerful part of it is that you can define what kind of framework you're going to use to create it. For example, here, the library is Feign. So if you're using Feign clients, so it's going to generate Feign clients for you, and then you can use it easily, which Kyoto doesn't give you. Kyoto only gives you OK HTTP, so you are bound to it, which basically not a big issue. You are, at the end of the day, dependent on the response and the error codes which you get back. So how you're going to invoke it, it's not really a big thing. Now, the last part, which is going pretty slow, it's a mixed bag, so I was telling you at the beginning, so I'm going to jump from one topic to another topic to another topic. Kafka schema management. So how many of you are working with Kafka somewhere in the application? Do you also have schema defined? No, yeah, OK. So we had it, and the schema is basically your data structure, which you publish to Kafka or consume from Kafka, or any other, basically, message broker. Every message broker has a schema management, to be honest. But the schema file is in a language which is pretty difficult to learn. Or, let's put it this way, it's not very intuitive. So when you're trying it to write first time, you really need to do a lot of Googling, or, OK, I should not say Google because I work for Microsoft. You should do a lot of Bing to find out, what exactly this should do if I have to make it a Boolean or a required or conditionally required, et cetera, et cetera. So we were all Java developers. We wanted to do it in a Java way. So Apache provides you a schema builder, which you can write your schemas in a Java way, and then use Maven plugin to generate your schemas, use another Maven plugin to generate your POJOs, because you're consuming applications, and the producer applications will need those POJOs to post those events to Kafka or any other message broker. And then, basically, it streamlines it. You don't need to learn any other language to create or generate a schema. How does it look like, actually? Let me show you. This is actually the fun demo, which I pretty much like. So what it does is defines a schema. My schema is pretty much simple, so I have two fields, and a first name and a last name. I define a namespace, and that's it. What it does at the later on is create the schema file. So I have some file operation here, which generates basically the file for me. Standard stuff. But the magic happens in POM. And here, basically, I invoke with Maven exec plugin my schema class, which basically, generate the AVSC file or the schema file, and then puts it somewhere. And it looks like this if I run it. I have 5 minutes, so I have to go fast. It looks like this when you run it. But this is only useful for your message broker. So you can post this to your message broker, and message broker knows this is your data model. But if you're using in your Java repositories, you do need Java POJOs to work with. So then comes the second one, which is basically the Avro plugin from Apache, which takes in that Avro file and creates POJOs out of it. So it's going to create the user.java for me. And it has all the builder properties, builder methods to build your object and use it within your producer and consumer. So it helped us a lot because we didn't need to learn a new language. We used Java all the way from beginning to end and used a couple of Maven plugins to generate everything out of it. Since I have 5 minutes and I cannot finish, so I'm going to only do the config management. How many of you are using Spring Profile? Okay, quite a lot. How many of you are using Spring Cloud as well? Okay, so we, thanks. We had a dilemma beginning of our project that how we're going to divide our properties. And we came up with, application.yaml or application.properties, and you put it in the repository itself, and then you read it. But soon it came that there are a lot of properties which are, shareable. So we put it in Spring Cloud config, and we read it out of it. Then came the problem, every environment has a different URL, so a different port number, different service repositories, different blah, blah, blah. So we need to put something out of it. So we created a cloud config server. But the cloud config server also initializes some of the beans. One of them was Kafka, and that Kafka bean, if you change some properties, it is a singleton, so you have to restart your application, basically. So every consuming application has to be restarted if you change those singleton bean properties. There is no other choice, basically. Even if you listen to it, it's not going to happen. So we changed our pipeline only for the config server so that it actually restarts all the other microservices or consuming applications which are reading it. Then we also put the dev, test, prod, everything in the config server as well, so that if a microservice is deployed with a profile dev, it will only read dev profiles and prod, etc., etc. But that, we changed it a bit. So what we did, we only made the config server profile aware. So we deployed config server with the profile and all the microservices without a profile. So microservice will read the profile properties information from config server as if the config server gives the information same for every environment. But smartly enough, the config server is aware of the profile itself, so it only exposes the properties which are actually valid for that environment itself. So what it helped us, the profile management only happened in config server centrally. All other repositories, consuming application didn't need to care about it. And made our development pretty easier, so you don't need to worry about profiling anymore. I have 2 minutes left. I'm going to talk this one as a last, then I'm going to pause. This also helped us a lot. When we started our project, there were quite a lot of testers in our team who had nothing to do because we didn't have any application to test. So we thought a different way of adding the unit test. So we wrote our unit test in Gherkin and Cucumber engine. So every unit test was natural language type. So if I invoke a user API with a property A, I get a user back with ID blah, blah, blah. And all this code, all this Cucumber was actually backed by unit test, which had typical mocks and test containers, etc., blah, blah, blah. What it also did, Cucumber, out-of-the-box feature, gives you a nice report back. And we published that to our wiki, which was very helpful at the end of the day to the product owners and the business analysts to see, hey, we developed this feature, and this is also tested. So I'm quite happy to see this report back as a stakeholder that you guys are doing a job. And on that whole process, we also involved our testers as well before even the testable applications are available on an environment to also contribute to our development process. It also helped us to extract those scenarios and put it on integration test. The only thing we changed was remove the unit test and mocks and test containers out of it and put actual API calls and all other database calls which are required for those scenarios. So you also can reuse those scenarios in your integration test later on. Or let's go one step further. If you have unit and integration tests in the same repository, your scenarios are being called from a different build step, once for unit test, once for integration test. So you are actually making your repository tests are also quite smarter depending on which pipeline or workflow step you are actually working on. I'm going to stop talking because the time I have is over. If you have questions, this is the time to ask. First of all, wait. Did I teach you something new today? Cool, thanks. Then, go ahead. No? Okay. Cool, then everything is understandable, I guess. Thanks for being, oh, yeah.
Your example about config servers managing the profiles.
Yeah.
So you have multiple config servers?
No, but you can choose to have multiple config servers, but your Spring, you define in your consuming application which config server you are actually calling. And there you don't define anything other than the config server path. So you can have multiple, that's also fine. Actually, no. One for each environment. And each environment has a profile. Yeah. So you're not running same config server multiple times in the same environment. Thank you.